everyone. I am very happy to be the first speaker today. My name is Julia Gruszczynska. If you're curious how my surname sounds, that's how it is. And it's my utmost pleasure to tell you about web components. And I hope you all had your coffee and you're nice and fresh and ready to learn. But if not, then we will start with something a little bit more interactive. There will be a little quiz. So I have some rewards. They are sponsored by Arnold from HQ, and they are really, really tasty, so it's worth it. And the rules are there will be some pieces of code visible on the screen, and it's all JavaScript front-end code. And you can try and tell me what library this comes from. So are you ready? I was told not to do are you ready? Are you ready? Yes, perfect. So, question one, what is this? Where does this come from? Someone said something? Yes, perfect. Oh, sorry, my aim is terrible. But yes, it's React. And question number two. What is this? Where does this come from? You have to speak louder because I'm also, okay. It's beautiful. And question three. What's this? That's really tiny. Yes, I don't know who was first. Just come and get your mini waffle. And the last question, what's this? You should know that. Yes, but to be more precise, yes, it's the one we all hate. There is also, there are two left, so you have to share. So my timer is not running. So all these things, what do they have in common? These are all front-end frameworks, and what do all these front-end frameworks do? Except that they ignite fiery debates on which one is better, and then people argue, and yes. So why do we even have these things? So they solve some common problems that we step on when writing front-end, and they give us some structure for the project. They bring some architecture. They very often add reactivity. So our DOM gets bind to the data, and then it gets updated whenever the data changes. They come with some build tools and CLIs and a lot of developer-focused improvements. There are usually some dedicated state management, some router, plugins from communities and so on. I mean, you name it, you have it, it's somewhere there. But except of all this, apart from all these very nice and useful tools, they also bring componentization, so we can organize our code in smaller modules. So what is a component? It's a small module that we can reuse and configure somehow. So all these snippets that you saw at the beginning and you were fighting for tasty waffles, these were components from different frameworks. So it's like a building block. It usually has some API that you can interact with and change the behavior of that. So building block that is configurable. And if we look from this perspective, if we look at native elements, they also behave like that. So here we see an input, and it has an attribute of range, and when we add that attribute to it, it will look like a slider. But if we take this attribute away, it's changing into the text box, and we can type some text, and there's even more to it, because if we put it inside the form and we have a button, then we press it, then the form somehow reads the input. So there's a lot going on here, and we can look at native elements also as components. So what that tells us is that there is already something in the browser that allows this componentization, because these elements, they are somewhere already there. So around 10 years ago, someone had a great idea to open this mechanism up to developers so they can create their own custom HTML elements and program its behavior. And to make long story short, now we have web components in every browser. For that, to create them, we have two stable APIs, Shadow DOM, that allows encapsulation. That's something I didn't say at the beginning. That's also a feature of a component. It allows to encapsulate some logic and very often also styles in this one module of code. So we have Shadow DOM to do that in the browser, and we have custom elements to tell the browser that we have made some custom element, and here's the tag, and here's the class that is responsible for its behavior. So what is a web component? You can think about it as a universal way to extend the DOM of the browser. So you can add your own custom elements with logic and with styles and reuse it across one project or multiple projects. So this might not sound like a big deal, but I think it is actually a pretty big deal to have that fundamental way of writing code straight in the browser. So what can we build with web components? We can build design systems like UI library. You should know that by now. We have a UI library. It's a set of web components, basic building blocks of your UI that will work everywhere, and it's framework agnostic. So we can also build standalone components and build on the encapsulation possibilities. You can build your own piece of UI if you're missing something. It can be pretty simple, like emoji picker or carousel, or it can be a little bit more complicated. That's one of my favorite web components. It's for displaying models, 3D models in the browser, and in this custom element, there's this huge 3JS library encapsulated. And if you look at the code example here, then the implementation is pretty simple. So you just put a link to the source, but under the hood, there's a lot going on there. And the third thing we can build with web components, it's an entire application. And they come handy with when it comes to micro front-end architecture. So that's when we take our big app and we slice it into smaller apps that work independently from each other, and then they can communicate with each other, and they are wrapped in this shell part. But I'm not going to talk about that because it's a pretty big topic, and then this talk would be really long. But you should also know, especially after yesterday, that the Backoffice is an application built entirely with web components as a base. Not only base for the application, but mostly base for its extension system. So that's the fundament of it. So maybe let's get a little bit more practical, and let's see how we can add a vanilla JS component as an extension to the Backoffice. So we have this lovely Umbraco package.json file, where we have a name for our vanilla web components component dashboard. It's going to be of type dashboard, and we're going to show it under the content section. And these two lines are most important for us because here we link to the file itself, where we're going to write the component, and here we have a name for our custom element. That's a terrible name. Don't copy the names that are in this demo. They are absolutely horrible. So what we have to do to make a web component, we need a class where we're going to put all the behaviors. So We have a lovely class called myVanillaDashboard It's going to be a counter. And that's going to extend HTML element class that provides a shared interface for all the elements in the browser. So what lives there are all the DOM methods like attaching a child, removing a child, all the properties like IDs, and so on. So we want our custom elements to have all the possibilities that other native elements have. So next step, we need to put shadow root into our component. We have to attach a shadow DOM to it, so we get a nice encapsulated tiny DOM where we can do whatever we want. And this is how we do it. In the constructor of this class, we call this attach shadow with mode of open. There is also a closed mode, but the open mode is better. And for now, let's stop at that. So now when we have that, we will have our tiny little DOM with encapsulated styles attached to our component. So let's put something inside. And to do that, we need to utilize the template element. So we're going to ask document to create this template, and we're going to put some stuff inside this template element. There will be two UUI buttons, increment and decrement, and some span to show the result. So what is a template element? It's like a container for your HTML for later. It doesn't get rendered until you actually attach it somewhere as a child. So it's a storage, like a box for HTML for later use. So how do we... So now we have to take what we have in this template and put it inside our shadow DOM. And how do we do that? Oh, we also need something to store the count. So in the connected callback, we're gonna call this shadow root that we attached to our element, and we're gonna call append child on it. And we're gonna take this template. It has some inbuilt functionalities to deep clone every DOM node, and that's what we are doing here. And connected callback is also part of Web Components API. And this runs when the element was already instantiated and it's connected to the DOM structure. So how it goes, first, the browser instantiates this class, and then it puts it where it belongs in the DOM, in the structure. But we cannot see this yet because we are missing one line to do just that, to tell the browser that, hey, when you see this weird vanilla web dashboard tag, the one we define in here in the package, in the Umbraco package file, when you see this tag, then you have to create an instance of this class and put it inside the DOM. So with this file, with this line, we have everything we need to have this very useful Backoffice extension that's going to count clicks. So let's see what we have in here. We have the vanilla dashboard. Here is our shadow root that we attached in the constructor, some styles, 2 buttons, and the span. But if we click on the buttons, then nothing will happen because obviously we didn't set this up yet. So let's take a look. We need to add some more code to make this work. So now in the connected callback, we have 2 event listeners on the buttons, added on the buttons. That's a good place for adding event listeners because you have the DOM created at that point. Then we have a call to a render method that we need to update the value of the span. We have some getter and setter on the count, so we will run render every time we set the count, and so on. So now we have a working counter, but what if we don't want to count from 0, but we want to count from 5 or whatever value? So it would be nice to make this web component somehow configurable and create some API for it. So what we're aiming for is to add an attribute of count, saying 8, and having the value displayed in the DOM. So we need a little bit more to achieve that. And on line 20, you can see that now we have a static getter for observed attributes. That's also part of Web Components native API. That returns some array of strings where we put the names of our attributes. So now whenever count changes, some logic will be run, and this is on line 35. You can see there's an attribute change callback. That's another part of Web Components API. And here we can grab the new value or the old value from our observed attribute and do whatever we want with it. So in this case, we assign it to the count. So what is the difference between property and attribute? Because this was confusing for me for quite a while. So I thought I'm going to share the outcome of what I learned. So property is on an object. This is on our class, the count on our class. Meanwhile, the attribute is part of an HTML markup. And that leads, property can be of any data type. We can have null, we can have undefined property, we can have string, we can have number, we can have reference type, so objects, arrays, you name it. So there is a problem here because attribute can only be a string because markup is a string. So attributes, they are only strings or booleans. So there has to be some conversion implemented if we want to make it proper. And in the native elements, not all the properties have attributes, and vice versa. Sometimes something is only an attribute, and sometimes something is only property, and sometimes something has both. And sometimes the value is reflected between the two, so whatever you pass to the attribute goes to the property and back from the property to the attributes, but sometimes it doesn't. So it all depends. But what is important that our public properties and attributes, that's what what constitutes the public API of the component. So if you come up with a name for your attribute, it has to be good, and because, well, it will stay there and people will rely on it. So take input as an example. We have an attribute called passport, and then, attribute called ID, and another attribute called value. So ID is the type of attribute that is reflected both ways. If you change the property, then you will see the attribute updated. If you change the attribute, then the property will be updated. But the value is a little bit different. So this is like initial value for a property. So this attribute gets to be read once. The value, the property on an object will be set to this value, and then it's forgotten forever. So no matter what you do later on, it will not update the actual property. That's how we can also configure that behavior in custom elements. So we can have properties and attributes that follow each other. But the bare Web Components API is not super friendly. So there is a lot to set this up. And the more advanced it becomes, the more code we have to write. There are a lot of helpers to make Web Components development easier. And in the back office, we use lit. And what lit does is it has a reactivity built into it, so it will update the DOM. It will also it will also make some properties reactive, so the DOM will also get updated. All the properties get corresponding attributes. It will attach this shadow root, and then it will also give us some nice way to write our templates, so we don't have to make this whole huge block. So now you might think, what am I doing here, and why am I showing you the counter? Because you know how to write counters in JavaScript, because, well, are you 6-year-olds? No. But then I'm going to ask you, can you write something like this? So that's another very useful extension to the back office, and it's a Umbraco Rabbit dashboard. if we click on the coffee, then the rabbit will drink some and it will comment on the coffee quality. So let's vivisect this bunny a bit. So it has a head, it has a belly, and in the belly we have two children, two hens, and in one hand the rabbit has the coffee component. We use slots to display one element inside the other custom element. So now that we know that if we click on the coffee, something will happen, then let's go to the code and let's look how this is all wired up. So in the coffee component, we have our coffee element class, and this time it extends lit element instead of ht element, so we get all the nice stuff that lit gives us from this base class. We have another nice helper, a decorator. This is all TypeScript, by the way. That's an equivalent of custom elements.define. Here is our coffee strength property. That's gonna be a reactive one. So this with this property decorator, this automatically gets an attribute to follow. And we can configure it a bit. So we can pass the number, so we get the proper data conversion between string and whatever our property data type is. We can also add reflect true to this option object, and then the value of our property, if that changes, then it's going to be reflected to the attribute, which is very useful to conditionally style some element. We're going to see that later. And finally, if we have something complex, like array of users, we don't need attribute for that because, well, it wouldn't make much sense to have one. So back to the coffee, we have our strength defined here. And in the rabbit component, we will initialize this strength to 5. And then again, if we click, we get the comment. So let's hear how the clicking happens. So the coffee element, it listens to the click event, and then it runs drink coffee method, where it dispatches a new event, drink coffee. And this new event has an options object, and there inside you can see two options, bubbles, and this event only bubbles if the strength of the coffee is greater than 10. If the coffee is weak, then the event does not bubble. And there's another property called composed that is now set to false. So events are a way of communicating between components, between children and ancestors. And that's also part of the public API of the component. So now let's bump up the strength of this coffee to 11, because all the funky things go to 11. So now this event will bubble. So let's see what happens then. So coffee is really strong, and unsurprisingly, the rabbit does not like it, and it gets bubbles in its belly, and the belly gets an attribute called disrupted for a while. Then it passes. So let's see how this works. So apart from this event listener that will run the comment method, where we're going to access the strength from the coffee element, and we're going to differentiate on that. We also have another listener on the belly, which is an ancestor of the coffee and the hand, and this will run the upset stomach method. And this thing will toggle has disrupted belly property of this class, that with this state decorator, we can make a private reactive property. So not a part of API, but something that still triggers the reactivity cycle. And here we bind this to the template. So every time, so the value of disrupted attribute and property of our belly component will always be equal to whatever the rabbit holds under has disrupted belly. So meanwhile, in the belly of the rabbit, we have this property defined. It's a Boolean, and this one has the reflect set to true, which we are using to conditionally style this element. So if our host element has an attribute of disrupted, we're going to change the background to this belly. So how did that happen? That before this event listener didn't work, it was there all the time. So the bubbling property disables the entire phase of DOM event. It has 3 phases. When we dispatch the DOM event, it doesn't really go from the target to the top, but it goes from the top to the target and back, like that. So the first phase is a capture phase, but you usually don't care about it because all the event listeners, they listen to the bubbling phase by default. So if we disable this entire thing, then no ancestor of this element will be able to listen to our event unless we do some more logic. So that's how it works. So you may think this is great. That's exactly the same like in the regular DOM, but sorry, no, it's not entirely the same. And let's see if we can catch this drink coffee event on the window element. So we add another event listener in the connected callback, and it's going to show an alert if this event is caught. But if we click on the coffee, nothing happens. And that is because of this line. So let's change it to true, and let's see if we're going to see the alert. So now we get this annoying alert. So something has changed here. So what does it mean that event is composed? It means that it will be able to run away from the shadow DOM. So that's where you can cross the encapsulation. So if it's false, then it will only get to the target, to the host element, and no further. But if we set compose to true, then it's going to escape the shadow DOM and fly up as long as it can. There's one more thing happening there. The encapsulation is not broken entirely because the events, the composed events, they get retargeted. So the target of your event is not the element inside your shadow DOM, even though that dispatched it, but it's now the host element. So when it crosses the shadow border, now your target is the host element, so you cannot know from the outside what was inside shadow DOM. There are ways to do that, but that's going to be in part 3, maybe. So you may think, all right, this is all nice, but what if I don't like it, I hate it, I want to use something else? Well, the good news is you can use something else, and that's the beauty of web components. So let's see. Here, now our rabbit has a carrot, and it likes the carrot. It's good for your eyes. Carrot, it's just a button, and inside the button we have some SVG and some styles. But the real surprise is inside the code, because now we have a third extension that is a little bit different. That's the entire front-end setup here. So this time it's an entry point, so it's just a script we attach to our Backoffice, and it's available from the start. And here we link it to the outcome of our Svelte setup this time. That's a compiler that's gonna compile your code to native JavaScript. It also gives you reactivity and so on. So this is our Svelte component. We have a little hack here that will allow us to dispatch an event that is composed, so we can communicate with the outside world from this carrot. And every time we click on the carrot, we're going to dispatch this eat carrot event. So meanwhile, in the bunny, all we need to do is we have to drop this carrot tag. And because it's registered from the beginning, because we added as an entry point, it's going to be available. Then we listen to the event, the eat carrot event, that the carrot dispatches, and then the head says something else. So that's how it works. So what is this? It's a lit setup with svelte component inside, and they still can talk together. It's a simple example, but it showcases that because web components live in the browser and because they rely on the DOM itself, then you can make two different tools cooperate just by creating these public APIs and settling up some events. You can also pass down something from the rabbit to the carrot, of course. So this is how web components are interoperable. I think it's pretty cool. I don't know what you think. I hope you agree. So that's the end of Web Components Crash Course Part 2 Advanced Wing. My name is Julia Gruszczynska. You can check out the demo. It's on my GitHub. If you want, if you have some questions, then come to me and I will try to answer. And if you want to know more about how to extend the Backoffice, then you should go to the CMS backstage and find Niels there. He will be there. I don't remember when. You have to check in the app, but he will demo how to extend the Backoffice and how to create, I think, property editor. And there is also Callum's talk pretty soon in the Alfred and Camilla 10, where he's going to tell you a little bit about how to set up a modern front-end project with Vite and build a property editor with that. Thank you very much. I hope you like it. And yes.